those wooden things, or did someone make them?
Mr. McConnelly made them with Mr. Baker. All right, so here we go. So AgF solution. So we have your anode options and you have your cathode options. So your Ag plus would be over here. Ag plus is going to gain an electron, turn into Ag. If you look at the standard reduction potentials, you will get 0.8. We need 0.8 volts for that to happen. And on the other side here, we have F minus, so that's right at the top. F2 plus 2 electrons yields 2F minus, and that's going to be 2.87. 2.87 volts. And then you have water. So I already have it in my notes. I don't know why I'm looking. So for the anode, we got 2H2O yields O2 plus 4H plus. No. Am I writing this wrong? That's right. That's right. Did I write that in reverse though? Yeah, okay. So I flipped it. In my notes, I flipped this reaction. It doesn't matter. I'm showing the water losing the electrons, but it's the same as the one on the chart there. And then the cathode, the water is gaining electrons here. So 2H2O plus 2 electrons yields H2 gas plus 2OH minus, and that is negative 0.83 volts. All right. So, who can tell me, someone besides Andrew, which one is going to be our anode winner, which one's going to be our cathode winner?
The water will be the anode.
Yep.
And the Ag.
Yep. Good. So then, if we want to find, good job. So if we want to find the E cell, Joe, what do we subtract? What two numbers? I mean, what's the order here?
0.8 minus 1.23.
0.8 minus 1.23, and we get negative 0.43. Yep, negative 0.43 volts. And I forgot the first thing I asked you was to write the half reactions. There it is. If you want to write the overall reaction, what would we do? How would we show that? Wanted to write the overall balanced equation for this electrolytic cell. Put the two together, right. So I would advise taking them, whatever they give you as far as the standard reduction potentials, I would advise taking those. But I think, yeah, because I flipped that one. So where is silver?
Would you have to multiply it to get the same amount of electrons on both sides and stuff like that?
Nope, no, it's already good to go.
Alright.
So you would ignore the electrons. But yeah, you could combine them. But what did I ask you to do the half reactions?
Yeah.
Yeah, half. So the half reactions are given to you. All right, so that's that. So with the electrolytic cells, if it's molten, it's easy. You just look at the ions. If it's in solution, don't forget the water, and then you just have to figure out which one to pick. Subtract cathode minus anode. Again, though, the concepts that I think are more important for the test is understanding what's happening. The anion is always going to be oxidized. In these electrolytic cells, your anode is always going to have your anions. That means oxidation. So that's always going to happen. Your cations are always going to the cathode. That means reduction. So the cations are always getting reduced. If that happens to be the one that actually reacts, that happens every time. As far as the water, it just depends on what ions you put in. Depends on whether the water's being used or not. In other words, which one's going to react. Which one's more easily reduced or oxidized. That's the point. So that's the part I care more about, is understanding what's happening. This is easy. Anyone can do the math. Grade school kid, probably. Middle school, maybe? Negatives are tough for some little kids. Anyways, questions with this? All right, last thing here. Last new thing for the year. Probably will get cut off a little bit, but that's okay. We'll finish it tomorrow. But this will be the last new stuff. Here we go. So I'm going to just write a sample problem down. This is called quantitative electrolysis. Quantitative electrolysis. You can determine the mass or volume of a species in an electrolytic cell. So a question could say, given the following electrolytic cell, how many grams of potassium metal will be formed? How many liters of oxygen gas will be produced? So how are we going to do this? I'll give you the process first. I'll give you the process. And the process is kind of a sequence of thought steps that you would think through to get this correct. Plus there is an equation on your equation sheet. So you first start with the current. Question almost always gives you the current. Sometimes it doesn't, you have to work backwards, but we'll start with the straightforward ones first. Then you're going to turn that into charge. So that's coulombs. So current would be amps, charge would be coulombs. After charge would be the number of electrons. Or we always say moles of electrons, so I'm just going to put that underneath, moles of electrons. After you get the moles of electrons, you can figure out the moles of the species. I say species because that could be a cation, anion, or it could be a metal, non-metal, a gas. It depends. And then, so that's just moles. There's no little parentheses there. And then grams or liters of the substance. I should really say species, but substance. So this is the thought process. So when I write this sample problem down, and then I'll show you what equation we're going to be using. I want you to use this to try and see, I'll give you a few minutes to see how far you can get without me going over it. Okay? And the equation we're going to be using, I think, yeah, it's on there. I equals Q over T. Yes, it's the last one. It's the only one we haven't used yet. I equals Q over T. What's I?
Amps.
Amps. So I is your amps.
Q is charge over time.
Q is charge. And this is time. Okay, so we're going to be using that. In charge, we think coulombs. Okay, charge is measured in coulombs. So I'm going to give you a sample problem. You're going to be using this equation. Let's just see how you do. All right. All right. So here's the question. Calculate the number of grams. Calculate the number of grams of aluminum. All right. Focus. The number of grams of aluminum produced in 1 hour by the electrolysis of molten AlCl3 if the electrical current is 10.0 amps, which is capital A, I believe, yes. Right, capital A for you guys, you electrical specialists. So, take a couple minutes here and use the process that I outlined and see if you can come up with the answer.
I'm assuming time has to be in seconds.
Yeah, I was going to let you flounder for a little while,
I'm sorry.
but that's okay. Yes, time has to be in seconds. Yeah, it's molten. So time has to be in seconds. Really, we're just focused with the aluminum here, not the Cl. So you do not need the standard reduction potentials for this.
You need a reaction or a reference.
Sort of. You just need I equals Q over T. You need to use this.
Yeah, once you find coulombs, so you need to get converted.
Yeah, okay, do what you gotta do.
We're gonna convert it.
Yeah, we need to convert things. Yes, there's a lot of converting in this problem.
I don't know how to convert without my reference state.
You're okay. That's fair. Andrew, how'd you know it was seconds?
Physics.
I just assumed
What's that?
Because it's amps or coulomb per second.
Right. Let's make that clear. Amps is coulombs.
Yeah, I was just thinking.
Per
in
second.
physics, we always use seconds.
Yeah, no.
Seconds is the
Like
standard.
with currents. And
Yeah, I
stuff.
just wanted to.
Also,
Get it
on
out
the
there for
reference
everybody.
table, right next to
Does it
time,
tell you?
says seconds.
What a handy dandy thing this is.
I just remember.
Why remember anything when it's on the reference table?
Because someday you might have to teach it. Or tutor somebody.
What's the 30%? What's grade?
There it is. 96,000.
96,485.
485.
That's how many coulombs are in a mole of electrons. Per mole of electron.
Oh.
96,485 coulombs per mole of electrons.
How can we, wait, what? How do you convert coulombs to moles?
First, you got the current. Did you
Yeah.
convert to coulombs?
Yeah.
Now you need moles of electrons using Faraday's constant.
How do I do that?
Well, you know how many coulombs, right?
Yeah.
You got Q. So Q is just coulombs. Faraday's constant is coulombs per mole of electrons.
So I have to divide it by that.
So if you know the coulombs, you can figure out moles of
Yes,
electrons.
I have to divide by 96,000.
Give you another minute because I want to make sure I have time to go over it and then assign your homework. Joe, is that still recording or is it doing storage full nonsense?
It's still recording.
Alright, good.
Should be. Storage is clear.
Yeah, but it's having a hard time uploading things and getting nervous.
That's probably the school's Wi-Fi.
Probably.
Might have even blocked YouTube because they blocked everything out.
It's just I can't put it online for precedent until it's got to work.
I would honestly just take it over to the library and use their Wi-Fi.
It's much faster. Is
Yeah,
that where
plus-
it is?
Plus,
Is that
there's
the-
like tons of people not using it. They're all using
It's,
school.
there's a bunch of routers
Yeah.
all throughout the school. You can see them on like the hallway. when you see
I have one right here, don't I?
Yeah, but it matters how many people are on it.
Yeah,
Like
how many
all those
people are on the
laptops over there will be on it, I think.
Okay.
And it depends
Like
if
at
they're
the
being
library,
used.
there's maybe like
Yeah, and
One or
everyone's
two
pretty
people.
much
Okay.
connected to the Wi-Fi.
All right.
yeah that too.
Just use this sheet.
I'm just gonna write your homework in the box here. I'll try and remember to text it.
So I need to divide that by 3.
48, 54, 95. Here we go. I got a few minutes to get through this here. All right, so if we look for Q, we're solving for Q. It's going to be 10 equals Q over how many seconds in an hour? 3,600, right? Okay.
3, okay.
Yes. So Q is equal to?
360.
Yeah, 36000, right? That's coulombs. So we want now, so we got current charge, which is coulombs, then moles of electrons. So we know there's 96,485 coulombs in 1 mole of electrons. So I want to know how many moles of electrons if I have this many coulombs. So that's, in my brain, I think of a proportion, but you can do it, a different method there by just canceling. But it's either way, it's a proportion. This is how many are in 1 mole. So how many moles if we have 36,000? So X is equal to 0.373. We have 0.373 moles of electrons. So now we're going through our process. We're at moles of electrons. Now, how does that help us find moles of aluminum? So if you have 1 mole of aluminum, that really means you have 3 moles of electrons, right? Because Al forms Al plus 3. So how many moles of aluminum if we have 0.373 moles of electrons, right? So again, that's my rationale, that's my thought process. Again, it's a proportion. You can do it a different way, but you're canceling out units either way. So if 1 mole produces 3 moles of electrons, how many moles of aluminum produce 0.373 moles of electrons? X equals 0.124, right? Yeah. 0.124 moles of aluminum. So again, we went from coulombs, or amps to coulombs, to number of electrons using Faraday's constant, moles of electrons. Then this part you need to know, that there's 3 moles for every 1 mole of electron, or 3 moles of electrons for every 1 mole of aluminum. Now how do we find grams?
Just the gram formula.
Yeah, what's the gram formula, Mass?
27.
27, right? So multiply this by 27 grams per mole, and what do we get?
That's the no flex zone.
I got 3.35 grams.
Yes, 3.34.
3.34, yeah. So those 3 problems, practice that. All right, I will be after school. And that's it. No new stuff from here on out.